Hello everyone. If two pieces of metal touch each other in space, they will melt and fuse together. This is called cold welding or contact welding. This does not happen on Earth because our atmosphere creates a thin layer of oxidation between the two surfaces, preventing the welding process. It might seem like a major problem for satellites or space stations. But since these metals come from Earth, they are already coated with this protective layer. In reality, this phenomenon only happens in laboratories, where conditions are perfectly controlled. Most of us think we know all the planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We once had Pluto. But unfortunately, in 2006, it was no longer considered a planet. Instead, it became a member of the dwarf planets. But if I told you Pluto wasn't the only dwarf planet? We also have Ceres, Eris, Makemake, Haumea, Sedna, Orcus, Quaoar, Ixion, Varuna, Chaos, and many more unnamed ones. Ceres is especially interesting because its orbit around the Sun lies between Mars and Jupiter. When people think of black holes, the first image that comes to mind is a disc-shaped object sucking everything in from one side with nothing escaping the other, all thanks to science fiction movies and TV shows. In reality, a black hole is not much different from a star or a planet. It is a sphere with infinite gravitational pull, dragging everything in from all directions. The sun, yes, the very thing that keeps you alive, is not actually yellow. It only looks yellow because Earth's atmosphere scatters the light. The truth is, the sun emits all colors of the spectrum equally. This means the sun is, in fact, white. The phrase, "in space, no one can hear you scream," from the 1979 movie Alien is entirely correct. Because sound waves cannot travel through a vacuum. Unlike radio waves, sound waves need matter to propagate. But if you and a friend are both in spacesuits, and your radios fail, there is still a way to communicate. Press your helmets together. The helmets will act as a medium for sound to travel, allowing you to talk without radios. By talk, I mean screaming at the top of your lungs like a lunatic. Stars can be very strange. For example, there is one with the easy-to-remember name WISE 1828 plus 2650. But the interesting part isn't its name, it's its temperature. It is a brown dwarf and is the coldest star ever discovered, with temperatures ranging from -23 to -127 degrees Celsius. A star colder than you are. Another bizarre star is BPM 37093. As weird as the name is, its core is made up of 10 billion trillion carats of diamond. Neutron stars are even stranger. They are so dense that a single teaspoon of their matter weighs more than 100 million tons. Extraterrestrial life may exist somewhere in the universe. But so far, no evidence has been made public. What we do know is that there are many planets that could potentially support life, so-called habitable exoplanets. So far, we have found about 50 such planets, the closest being only 20 light-years away. However, we still have no way to confirm whether life truly exists there, only that the conditions are right. In April 2010, there was a report about an unidentified object in the galaxy M82. The object suddenly appeared and began emitting strange radio waves unlike anything we had ever observed before. Many theories were proposed, but none matched the observed data. Did you know our Milky Way galaxy is currently colliding with a smaller one? It's called the Sagittarius Dwarf Elliptical Galaxy, located about 70.000 light-years from Earth. Still, stars and planets are so far apart that collisions are extremely rare. A similar event will happen in a few billion years when the Andromeda Galaxy collides with ours, forming a much larger galaxy called Milkdromeda. UY Scuti is the largest star ever discovered. If placed at the center of our solar system, it would engulf everything up to Jupiter. IC 1101 is one of the largest galaxies we know of, containing about 100 million billion stars. To put that into perspective, our Milky Way only contains around 400 billion stars. But the largest structure in the observable universe was discovered in November 2013. It is called the Hercules Corona Borealis Great Wall. This structure is a galactic filament, a vast grouping of galaxies bound together by gravity. It is so enormous that scientists cannot explain its existence. It lies 10 billion light-years away, meaning we see it as it was 10 billion years ago, when the universe itself was only 13.7 billion years old. This means it had only about 3 billion years to form, something scientists say should be impossible. For comparison, our solar system alone took about 4.6 billion years to form. This structure is simply too large to exist. It's one of the scariest places many can think of, the most wonderful to others, a place we haven't really visited beyond low Earth orbit for over 30 years. This is space, music. We don't exactly know how many stars there are in the universe. We can make estimates though, but these estimations are limited by the technology available to us today. Once new and better technology comes along, we'll be able to see even further out into space and discover even more stars, and thus the estimated star count increases, but it's quite beautiful. Though, is it just seemingly flying among the stars like this at 100 MEAP parks per second? Except what you're seeing is not stars, these are galaxies, each galaxy containing millions, billions and even trillions of stars, most of which have their own planetary system with celestial bodies circling around it. Truly gives you a sense of scale, how small we are, just a tiny speck in this sea of space dust. But as we can't know for certain how many stars and or galaxies there are, let's take what we do know, and what we do know is that the observable universe contains at least 170 billion galaxies. We also know that their own average size galaxy, the Milky Way, has around 400 billion stars, so we can use that as a template. Now take 170 billion G galaxies, multiply that with 400 billion stars, and we get the number 68 sextillion possible stars in the cosmos. Black holes, one of the most mysterious objects in the universe. Everything about them is just taken to the extreme in one way or another. They twist and bend space and time around them. Some have been found to rotate close to half the speed of light. They can be smaller than an atom or billions of times more massive than the largest known star. They even stop time, and if you wanted to destroy one, well, you can't. Whatever you throw at it will just be added to its mass and energy. Lasers, bullets, nuclear warheads, a unicorn, the Avengers, a star, a galaxy, Google, plus another black hole, it would all just be consumed. But they're not completely indestructible, though they have one sworn enemy, one weakness: time. Wait long enough and eventually black holes evaporate because of something called Hawking radiation. This radiation causes the black hole to slowly lose mass over long periods of time. In part 1 I talked about the largest known galaxy in the observable universe, IC-111, which is estimated to contain about 100 trillion stars. On the other side of the spectrum, the smallest galaxy found so far is called Segue 2 and only contains the tiny amount of 1.000 stars. The galaxy is also very, very old. The stars are believed to have formed more than 12 billion years ago, meaning that they were most likely among the first street Mars to have formed in the universe. In 2023, we might have a reality TV show on Mars. This is if the Mars One project is successful. Mars One is an organization with the goal of establishing a permanent colony on Mars. Only last year people could apply to be one of the colonists to go there and thus leaving Earth forever to spend the rest of their lives on Mars. Over 200,000 people applied, but only 4 carefully selected individuals will be sent there in 2023, and every step of the cruise journey will be documented, and every 2 years 4 additional colonists will be sent to Mars, and the colonies plan to expand this way over time. The ISS is pretty cool and all, but you know what would be even more awesome? A big ass donut in space. No, I'm not even kidding here. That's at least what NASA thought would be a great idea back in 1975 when it was proposed to build a donut-shaped space station code named Stanford Taurus that would simulate artificial gravity and, almost like a little side note, support over 10,000 people. So of course they soon realized that going from Cerrero manned space stations to a space city of 10,000 people was kind of a big step, not to mention that it would take decades to get the material needed up there and more money than the whole economy of the United States. After NASA had successfully landed on the Moon in 1969 with Apollo 11, several other Apollo missions took place all the way up to the final Apollo 17 mission before the program was cancelled. But that was actually not the plan. NASA had already prepared for Apollo 18, 19 and 20 missions after Apollo 17. The plan was to get this colonized the moon with 6 people living on the lunar surface for up to 180 days, but the reason this never took place is of course almost as always money. A lot of you have probably at some point at least imagined what it would be like to be living in space, and well, it would be pretty uncomfortable. First of all, you'd had to work out every single day for several hours to prevent your bones and muscles from shrinking due to the lack of gravity. This includes your heart, which would become weaker and smaller due to the same effect. You'd also become taller in a very painful way as your invertible discs that cushion your spine would slowly drift away. You would see bright light flashes as you close your eyes because of the radiation that the Earth's atmosphere normally filters out. You will have trouble tasting things and feeling sick because of fluids in your body acting really weird, and cog bacteria also starts going crazy and becomes much more effective while your immune system starts weakening. Basically, if you get sick you can die, and as if that weren't enough reasons to not want to live in space, you can't have sex either. Like ever without gravity your blood pressure decreases, so for guys it just becomes impossible to get it up. A common myth about space that's often seen in movies and TV series is that asteroid fields are full of asteroids very close together and traveling through one is next to impossible or at least very dangerous. However, this isn't true at all. Space is gigantic and asteroid fields are no different, where the flying chunks of rocks are separated by huge distances. In fact, when nascent approached through the asteroid belts in our own solar system, it had a chance of 1 in a billion to actually get hit by an asteroid. A dream of many, including myself, I must say, is the prospect of someday being able to visit other stars, other planets, and maybe, just maybe, we'll find that we're not alone in this universe. But with the knowledge we have today, just how likely is that? Will we ever be able to take a quick road trip to Kepler 22b and check in at a local hotel for 50 space coins? Well, we can never know for a certain, but unfortunately the chances of that seem very slim at best. The biggest issue is that to get anywhere on such a large scale we need technology that can somehow overcome the light barrier, and when I say overcome I mean we really need to go much faster than the speed of light. The closest star, Alpha Centauri, is only 4.2 light-years away, meaning it would take 4.2 years to get there if we could travel at the speed of light, and I'm not even accounting for how long it would take to start and slow down during this journey. Time dilation, and the fact that it would take another 4.2 years if you wanted to go back or send some sort of message to people back on Earth. And with the current understanding we have of the universe, faster than light travel just isn't possible, at least not in the traditional sense. We have not observed anything going faster than the speed of light. So what options do we have? Well, believe it or not, but there is in fact a slight possibility that a version of the warp drive from Star Trek could become a reality sometime in the future. It's called the El Kua drive, and the way it works in theory is that it wouldn't move the ship at all, but instead moves and bends the space around the ship, and thus overcoming the light barrier without breaking any physical loss. Basically, instead of moving across a plane, you move parts of the plane to take you across it. But as you can understand, developing a technology that could bend space and time itself is not an easy task, if even possible. But at the moment, if we wanted to go faster than the speed of light while also overcoming complicated issues such as time travel, the theoretical Allier drive seemed to be our best bet.